Good morning, everybody. Good morning. Thank you for showing up on a Thursday morning, a 9 o'clock talk. I used to have philosophy lectures at Thursday morning on a 9 o'clock, and there would not be a full house like this for a philosophy lecture. I can tell you that much. So I want to start with a tiny bit of audience participation. So I can just about see you all around. But who in this room is an infrastructure person that is in charge of like Azure Active Directory or something like that? Okay, cool. All right. So only a couple of people about to get scared by this intro bit then. Because when I was putting this talk together, I started thinking about all the different ways that I'd dealt with usernames and passwords and authentication over the years. So I'm Graeme. I work as a cloud solution architect for Microsoft. I'm based in Perth, sunny Perth in Western Australia, but I'm English by nature. So I'm a little bit jet lagged, so kind of give me that today. When you're thinking about those colors at the end, say, Graeme was jet lagged. It's okay, yeah, we can agree. One step up. But I've been an engineer for most of my life, like 25 years or so, most of my professional career, I should say. And I thought about the ways that I dealt with users and passwords and things over the decades. And I started thinking about that first application I wrote, and it had a table in a database called user and a table called password. And I don't even know if those passwords were encrypted or hashed or anything like that, right? It was not a good place to be. But we didn't know any better back in the day. Or maybe some people did. I didn't know any better. Has anyone done that in here? Does anyone admit, yes, I'm not alone? Oh, wow. There's actually quite a few people in here. That's pretty cool. Who's done it twice inside the same organization with separate username and password tables for their applications? Okay, we're getting less and less people in here, but I will admit to that. I did that back in the day. We may have used an MD5 hash or something like that on the password, which, you know, I don't think you could crack that back in 1996, but it's not a good place to be. So we fast forward a few years, and we're now inside enterprises that have got Active Directory. So we all start changing to use Active Directory instead. Right? Because how hard can that be when we want to propagate user identity all the way through from a web application to row-level security in an Oracle database using Kerberos and things like that? And we have to reach out to find the two people in the known universe that can do Kerberos delegation from end to end all the way. And we annoy our corporate Active Directory team for groups all the time because we start plugging our application permissions into AD. And this is, again, not a good place to be in. It's really complicated, and it felt like it should be easier. So we come forward to about 2004, and it did get easy because Death Star came along. WS Star, WS Federation, WS Security. Who here has tried to roll their own secure token service? Because that's what we did in 2005. Nobody. Has nobody rolled their own STS? Oh, you're so lucky. Wow. I had sleepless nights. I thought my world was coming to an end trying to debug like WS Security. Oh my word, you're so lucky. That's great. But here we are. We're stuck in corporate enterprise space in around the sort of mid to early 2000s. And we look out to the internet and we see these platforms like Facebook and Twitter starting to grow and become really, really big, web scale. Right? They're becoming huge. They have millions of users, and they have these problems of authentication and authorization at scale. And they're starting to monetize themselves as well. So they open themselves up to third-party applications. So they become platforms. But they have a problem because they don't want their users handing over their usernames and passwords to, let's say, Pet Farm or something like that, so it can go and post a Twitter post for you. Because if you give it your username and password, well, you can do all so much more than that, right? It's got the keys to your kingdom. Actually, it made me laugh the other day because I was thinking about a lot of finance providers that will ask for your internet banking usernames and passwords still so that they can log on and scrape all your accounts and things like that. And people seem less concerned about handing that kind of information over than they did about allowing Pet Farm or something to post on their Twitter feed. But there you go. But they had this fundamental problem, which was, how do we enable Graeme, a user, to use this third-party application, Pet Farm, to give it delegated consent to access a resource owned by Facebook? And so we start to see the birth of protocols that today we all know and love as OAuth2 and OpenID Connect, etc., etc. And it's become really, really common currency now. Right? When you start a new ASP.NET application or a new Node application or a Spring Boot application, you're probably going to reach for OpenID Connect to deal with your authentication and your authorization concerns. I'll just say auth for now on because it's really long. I run out of time at the end, but I can save myself, I reckon, 35 seconds by breaking that into auth. But that's what we do. It's become super commonplace, whether it's Ping Identity or Okta or Azure Active Directory. Now, the reason I put this talk together is because a lot of my work involves helping customers that are trying to get these flows working, specifically within Azure Active Directory. And that sounds really, really easy. Right? I'm not going to go through today how to get up and running with a simple application because there's a billion sources on the internet that can do that better than I can. But what I find is I will get a phone call from a team saying, it's not working. It's like, well, okay, let's have a look how you set it up. And it becomes clear that there are lots of different pieces that all have to line up perfectly like the stars for these flows to work. You have an identity team that do their little piece. They're confident it's correct. You've got the API team, they own their little piece. They're confident that's correct. You've got the single-page application team or the native application team. They're convinced their bit's correct as well. And yet it doesn't work. And what always strikes me is people often don't quite understand how to go about diagnosing and debugging that next level to really understand why these flows aren't working. So that's really the aim for my session today. I want to show you the tools and the techniques that we can use to diagnose some common problems with OpenID Connect, MSAL, which is a Microsoft library for helping with that, and specifically Azure Active Directory. Now, we'll focus on that. A lot of the things I'll show you, they're fairly transferable because at the end of the day, a lot of this stuff is based off open specifications. Now, we're going to have a look at a flow called the PKCE flow, or PIXE, which is a newer flow for native applications, which, if you're writing mobile apps or single-page apps, you really should be using. And we'll have a look at how that kind of layers into this security story to create a more safe and secure application. We're going to break down JWTs, JSON Web Tokens. They're the common currency of OpenID Connect. But we're going to have a look inside them, and we're going to see how those different pieces in there relate to the concepts that we're talking about. And finally, we're going to dig into these concepts called scopes and groups and roles and try and pick apart what authorization really means and how best to go about it. So when I put my talks together, I like to hang things off a bit of a journey or a bit of a kind of fabricated story. And I first delivered it in July, actually, last year, which might not make sense as to why I've chosen this kind of scenario. But I re-delivered it in December. And in Australia, December and July are both months of the year that are associated with Christmas. And I thought about, well, Christmas is a really interesting problem to solve when you think about it. There's a lot of complicated logic in there. Right? How does Father Christmas get around the world in one night? That is like the traveling Santa problem that is just exploded in complexity. Can you imagine the business logic involved in that? The naughty nice list. You don't want that being hacked. Oh, your poor children. My kids would be so upset if the naughty nice list got hacked. So July is coming again, and let's have a look at Santa Web, which is Father Christmas's application for doing Christmas right. Now, Santa Web started life as an ASP.NET Web Forms application. I think it was built around 1998. There was an old COBOL system back in the day, but they kind of modernized it when .NET first came along. But it ran on-premise in a North Pole data center. And it had its own usernames and passwords tables. And things are getting a little bit complex with security. So Father Christmas set the elves out on a task to modernize the authentication. And as part of doing this, they migrated to one of the Azure North Pole data centers. Disclaimer, we don't have Azure North Pole data centers, I don't think. I think we might have had a submarine that we submerged up here at some point in time because it was cold down in the sea, but we don't have bricks and mortar data centers. But they wanted to leverage Office, and in doing so, they put all of their identities into Azure Active Directory. And they realized that Santa Web, legacy as it was, let's call it a heritage application, could lift and shift quite easily into the cloud, and they could put a thin veneer of OpenID Connect on top of it to make sure that they could authenticate Santa and the else into the application. So it's pretty straightforward, and they were very confident with that piece of the puzzle. But then they got one of the big four consultancy firms in because they wanted to digitally transform Christmas. And they were told, no, you need to make APIs because the API economy is ruling the world now. So the first thing they thought was, can we pull out all this business logic and create brand new APIs that sit in lambdas or functions or whatever the current modern tech stack is? And they had a look at the code and they quickly realized there's no unit tests. There's no real confidence when they deploy this stuff. They try not to touch it as little as they can anyway. So they decided that pulling all that logic out into these brand new APIs is a really, really bad idea. So instead, they just extracted as much as they could in place, and they put a bunch of APIs over that, new capabilities. And they decided to secure them with OAuth2, JSON Web Tokens. So this is all good so far. Santa has a crack team of elves who are user expert experienced developers. And they decided when they saw these APIs that they could create Santa Lite, which would transform the way that you did Christmas. You could get 35 to 40% efficiency by moving onto this new modern user interface. Very lightweight, very slick. It's beautiful. Okay. Now, this sounds kind of weird, but then if I think about many of my customers over the years, this is a really common thing that you see, right? Not all customers want to rewrite their legacy APIs, but most want to extract and create new capabilities so you can build new skins, new channel applications on top of it. And everyone's trying to use OpenID Connect. And that's what's happening here. But I have been told that something is not working down there, and they just don't know where to go about debugging this. So what we're going to do is we are going to leave the world of PowerPoint, and we're going to dive into the code to start having a look around and see if we can help the elves down there. So let's go. Now then, can everybody see my screen okay? No? Okay, that's not a good start, is it? What's it looking, what's the, oh.
The problem for us is a speaker, but you cannot fix it. We kind of can have a look here.
Okay, cool. Let's just try and up the font size as well for what it's worth. Alrighty. So, Santa Lite is a very simple React application. Oh, this is not good, is it? Oh, God. This could be a problem. Haha. I had a colleague from Perth, Amy, who did a talk, I think, in this room yesterday, and she came out and she was white as a sheet. And so, what happened? She's like, I think this happened, basically. Is it a cable problem? Oh, God. Okay. Wow. This talk's going to be really flat without this video, isn't it? Is there anything we can do over there, do you think, Mr. Technician man at the back? Or are we dead in the water here? It was like breathing on it. Made the problem, didn't it? Persevere. We can make this happen. Now then, what are we doing? Hey, try this one. Oh, we have a new dongle. Awesome. This one looks a bit more modern as well. Great. This is going to work. Okay, that's got, is it on the side? There we go. There we go. I've got a good feeling about this. Oh.
Did you change anything?
No, this is just standard settings on here. Right. That's. I was going to say, can you see that now? Oh, crap, look at that. All right. You stay right there. Don't move. Okay. But let's see if we can cobble through this. Oh, this is good. Ooh. Oh, you reckon? Okay. Shall we try that? Back to PowerPoint. Yeah, PowerPoint is... Oh, weird. What? Is it because I use VS Code? Is that what
Okay, who hates VS Code?
yeah, there's a hater in here.
There was someone yesterday who said they switched to another IDE. Like maybe disabled.
Really? You're serious? Wow. Well, I'm not going to be in VS Code for too long, so let's see how we go. It's kind of like holding together. Okay, cool. Wow. So, wow. This is great. So RLs created themselves a very simple React application. And when they did so, they had to make a choice up front to decide how to connect to Azure Active Directory. Did they use ADAL or did they use Node? These are both libraries that Microsoft have got up on NPM that allow you to basically hook into the flows that you need to authenticate and authorize people. Now, you can hopefully see from the screen, because it's... I planned that. That was like... Oh, okay, yeah. Let's try that. That's a good point, actually. How do you do that? Anyone know? Control-Shift-P. Light. The resolution, that's a good one as well. Toggle between... Oh, no way. Thank you. Yes. That's so good. I think I can go back to the keyboard then. Wow, that's one to remember. All right, so they had to make a choice. And luckily for us, the elves decided that, I can use the little red dot, they decided to use MSAL, stands for Microsoft Authentication Library. The other alternative is ADAL. I think that stands for Active Directory Authentication Library. Maybe Azure Active Directory Authentication Library, but that would be like ADAL, but it's ADAL. So why do I call this out? Well, look, the reason I call this out is if we go to NPM and we have a look at ADAL, what you'll see at the top is a whole bunch of things telling you ADAL will no longer receive feature improvements. You shouldn't use this library. It's on life support, etc., etc. Lots of warning flags. But when we look down here, still gets 445,000 weekly downloads. ADAL does not support more modern OIDC flows. There are some things it does do, which you can't do in MSAL, Microsoft Authentication Library. But the bottom line is when you start a new application, make sure you go for MSAL. So, like I said, just a public service announcement because that number's really quite scary. I think it still gets security fixes, but that's not the point. The point is that those flows themselves are considered less secure than the newer flows. So even if you're getting security fixes, you know, it's not great to be here. So when the elves set this up, they had to provide a tiny little bit of configuration to get things up and going. Specifically, they had to provide an authority and a client ID to MSAL. So these are really common things in OpenID Connect, very common terms. The authority. The authority is the thing that is the source of our identity. It's the thing we trust. If it tells us that somebody is if somebody is Santa, we trust them. We say, yes, that is Santa. We obey your instructions to us. So we're delegating our trust to the authority. Now, for Azure Active Directory, you'll always see an authority in this form. It's login.microsoftonline.com followed by a GUID. So that GUID is your tenant ID. It's your little slice of your identity inside a massively multi-tenanted identity solution that is used by like lots and lots of customers around the world. So everybody has their own tenant ID. That might be a little bit different to, say, Ping or Okta, where I think you can use your own fully qualified domain name for your authority. But in AAD, it's always figured like that. The next thing is the client ID. So this is, again, a really common component of all OpenID Connect flows. Every application that is involved in these flows is a unique client, and it is referenced somehow uniquely within that directory. So with Azure Active Directory, again, every application or client you register will get a GUID. Actually, that was interesting. I said application or client. So this is where we get onto the first wonderful part of Azure Active Directory. So let's go in to see if we can find these things inside the Azure portal. So I've got my own tenant here. It's called Graeme World. If you can get your own tenant, I highly recommend it, especially if you can get one with like the P2 licenses or something, because then you get to have a play around with conditional access and all these kind of really cool security features inside of AAD. But if you don't, everyone can get their own tenant, and you basically can get into the portal. And here we can see the tenant ID, which is A47. So this is good. The configuration matches up with what we saw in the VS Code application. Let's go and find the client. Now, you're not going to find the word client inside the portal here. AAD, I guess, I wouldn't say predates OpenID Connect, but it also supports things like SAML and WS Federations or some other flows. So the terms don't always match one-to-one with what you will see in OpenID Connect. So in AAD, we refer to these things as applications. Now, if we go into the app registrations, and we'll go into all apps, then what we will see down here is that we have an application called Santa Light, and it has an application. In fact, I should have actually scrolled in a little bit over here. Let's see if we can keep that on the screen over there. Santa Light, B10, and you'll even see what we're starting to do is tweak the portal more and more to kind of make the OpenID Connect terms a little bit more center place. So it's kind of a little bit of a help. But the important thing here is B102. So that should match up with what we have, not in that one, in this one, B102. So everything looks good. So let's start the app up and see what is going wrong. So you see it's a beautiful application. Those elves are pretty good designers at the end of the day. Oh, there's one tool I didn't start up in the background. Oh, I'm going to give my game away now. This is terrible. Nobody saw that. Saw nothing. He did not start Fiddler up. So let's go and sign in. And sign in. Okay, so the first thing that happens is we get taken away from our application. If you look in the URL, you can see we've left santalight.localtest.me, and we've gone to that authority. So this is the first important piece. We don't sign users in anymore. We don't take their usernames and passwords inside our app, because that's not very secure. Instead, we allow AAD to do that for us. So what I'm going to do is open up my little password manager. I think this one's now been considered insecure, hasn't it, as well? So it's terrible. In a security talk, I'm using insecure things. So we're going to sign in as Santa. And we'll put his password in. And we first get asked for some consent. So we talked earlier about the Facebook problem of asking our users for consent to do something on their behalf. And that's what we're seeing here. It's a standard consent. And we see this all the time in OpenID Connect. And what it's telling is that there's an application called Santa Light. And what it wants to do, the important one here, is it wants to sign you in and read your profile. Now, these little bits of text here are what we refer to as scopes inside of OpenID Connect. And a scope is really nothing more than a piece of text you can put in front of an end user that makes sense for them. They can understand it when they look at it. So don't think in terms of backend APIs. Think in terms of there are real people. What will they understand and what will mean something to them? So in our case, we're actually asking for a particular scope, which is called an OpenID scope. Now, OpenID Connect was kind of like an evolution on top of OAuth2. So if we go back, OAuth2 was never an authentication protocol. It was always about authorization. So it would give you consent to do something on behalf of a user, but it didn't care about who that user was. It wasn't telling you, here's their full name, here's their email, here's their phone number. It was all about, yes, Graeme is allowing you to do something. And lots of different ways to do authentication were kind of built on top of OAuth2. So Facebook had their own API to get your profile. Google had an API to get your profile. And the idea was you could ask for consent to call that API, but it was very non-standard. Lots of different ways of describing profiles. So OpenID Connect came along and unified all of that and said, we're going to create this thing called an OpenID scope that will give you a standard set of information about a user. So what we're going to do is click on here and see what happens. And boom, this must have been the problem that the elves had. Now, this is a really, really straightforward problem, but I do get customers calling me up because they're just not sure what's going on. And what we're being told is the redirect URI, remember I said we took you away from santalight.localtest.me? It does not match something that is configured inside Azure Active Directory. And this kind of makes sense, right? Because we're taking you away from your page, and eventually when you've signed in, we need to get you back there. So where do we send you to? Now, in the olden days, I think it's about 6 years ago, a lot of identity providers supported these things called wildcard redirects. So you could literally say to the identity provider, send me back here. Just don't ask any questions. That's OK. You don't need to know about this URL. But that's a really, really big security problem. Like, imagine if the Grinch wrote his own little application that looked like Santa Light, but it was hosted on grinch.localtest.me. And he could just blindly say to AAD, can you redirect someone back to here? So he could get tokens because people might not realize where they were actually being sent back to was a dodgy website. So OpenID Connect kind of formalized this and said, no, 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 okay, none of that anymore. You need to be very explicit to make sure that wherever you're being asked to get sent back to is registered in AAD. So with that, let's go to AAD and see if we can see what the problem is with this one. So we're going to go into AAD, and we'll pick the Santa Light application, V1. And what we can see over here is that we've got a single redirect URI configured. So we'll go and have a look at that. And this is quite a straightforward one. What we can see is that the redirect URI is wrong. It has sign-in OIDC on the end of it. So when this happened on my customer site, what had actually happened was that an application team had said to the identity team, hey, we want to set up a new AAD application. Here's our fully qualified domain name. And the identity team had assumed that the application was a .NET Core, ASP.NET Core application. So we'd just automatically gone and added the sign-in OID prefix on the end of it. Super simple to fix this one. They do get more complicated, I promise. We can just hit save on that. And then, just want to make sure this was definitely the right one, B102, yes it was. Let's go back again to santalight.localtest.me. Sign in. And we come back, and if all goes well, then here we are. Actually, why am I not signed in? Oh, I've had this happen before. Oh, it's one of those ones that's so annoying. Where did it go to? Everything's going wrong. Wow, my browser just disappeared as well. Let's try that again. I promise you this will work. So Santa, sign in. Sometimes if you leave the flows dangling for too long, then things just kind of like seem to time out inside MSAL and the flows don't actually complete. So what we can see here though is now we've signed Santa in. Welcome Santa, what do you want to do today? So what just really happened behind the scenes? So let's go back to the slide deck and we'll walk through the flow we've just seen. So we started off, Santa went to the browser and clicked logging into the SPA application. And what it did was it generated a redirect URL, and it took Santa off to Azure Active Directory to do the sign-in. And it passed a few little bits of information along with that call. It said, this is who I am. I'm Santa Light. This is my application. This is what I want to do. I want to sign Santa in. I want to authenticate him so I know who it is. This is where I want to go to after the flow. That was our redirect URL where we saw the problem. And here's some security information. There's a whole bunch of kind of cryptographic stuff. There's state, there's nonces, all to try and make everything a little bit more secure. Now, one of two things will happen for a single page application depending on what flow you're using. If you're using ADAL, then you're using the implicit flow. And the implicit flow is the one that's really not recommended anymore. And the reason for that is the implicit flow will send some security information directly back in the redirect as something like a hash fragment. So you might see a token with user credentials or an access token with permissions to call another API, but it's sent in a hash fragment, which means it can pass through proxies, it can pass through virtual appliances, all things that could happily log URLs. So I don't know about you, if you've ever gone into a corporate Splunk and done a search on HTTP logs, it can be quite enlightening sometimes, some of the things you see in the URLs that are kind of flowing through those systems. Now, the reason the implicit flow did this is because it had no way to be able to make another call back to Azure Active Directory to say, hey, like, can you give me this token? Here's something that you and I both know that is secret and secure. So if anyone's ever done a server-side MVC application, has anyone done server-side OpenID Connect? Then you might be familiar with a flow called the code flow. So the code flow is different because the backend server-side application can keep a secret. If you think of a single-page application, you can't keep a secret, right? It's a React tab. You get all the JavaScript, the HTML. You can peek inside that. There is nothing secret in that thing. But something running on a web server can keep a secret. And if that's something that both AAD and the web server know about, then we can treat this flow slightly differently. What we can do is we can send something opaque back with the redirect. A code, we call it. It's meaningless on its own. It's just some unique identifier to that authentication flow that's just happened inside of Azure Active Directory. So we can send this code back. If you can get hold of that, if you intercept it in transit, you can't do anything with it. You could go to Azure Active Directory and say, hey, here's a code. Can you give me the token? AAD will just go, well, no, who are you? But if we can get that back to the server-side application, it has a shared secret, and it can say to AAD, hey, here's a code, but here's my secret to prove that I am the application that actually requested this code in the first place. And AAD will go, ah, cool, yes, well, I shall give you a token. So PKCE kind of brings a little bit of this to our single-page applications. We can't have a persistent secret, but what we can do is we can make a secret up on the fly inside the single-page application, a one-time secret. Imagine we just create some random bytes and we turn it into a base 64 string, something like that. And then we can run a cryptographic function over that. We can SHA it. And then we can say to AAD, hey, here's the sign-in request. By the way, here's a SHA of a secret. Nobody else knows what that secret is. So AAD, after it's completed the authentication, can then send the code back out to the single-page application. And then the single-page application can make a call back to Azure Active Directory. And it can say, here's the code. And by the way, here's the plain text that I originally used to create that SHA in the first place. So what we've done is we've bound the initial request for the authentication with the request to get the token at the end. So we know in no uncertain terms that it is the right thing that is actually asking for that security token. So that happens on a back channel flow, which means that we're not flowing security tokens through URLs that are being logged by proxies, etc., and things like that anymore. So that's PKCE in theory. Now, I think you probably noticed, I span up a tool called Fiddler in the background to try and actually capture this so we could have a look on the wire at what it looks like. So there's a whole bunch of requests in here, and I'm going to see if we can pick the right one. So let's start with, I think, what looks like one of the first calls to Azure Active Directory. So this is the thing that kicks off the flow. And there's a bunch of information, as we spoke about. We've got the client ID, which was our Santa Light application. We have these scopes, these delegated consent things that we're asking for. So we briefly talked about that, and you can see that there's one in here called OpenID. The other ones, MSAL won't let you remove those. I'm not quite sure why, but it's impossible with MSAL just to do a flow that is just for OpenID. It's entirely possible within OpenID Connect, but just not MSAL. We have the redirect URI. We've spoke about that one already. And this is the interesting bit here. What we're saying is we actually want a code to come back. We don't want a token to come back. And down here, we can see we've got 2 bits of information that refer to this. We've got the code challenge method, which in our case is S256. It's a SHA-256 we're sending it. And there, the code challenge. So that's the SHA. So Santa went through, he signed in, and then eventually, and let's see if we can find the right one here. I think it's this one. Let's see. It's normally the one just before we go back to the application. So yeah, here we go. Cool. After the flow was completed, we got sent back a HTML page that basically replaced the location with one that has a code on the end of it. So that's how we do the redirect back to Santa Light in this scenario with the code. And then the final piece of the puzzle is there's another call at the very end back down to Azure Active Directory. Let's see if we can just get into this one. So most of the information in here is the same apart from these 2 bits down here. So here we're saying grant type authorization code, which in OpenID Connect means give me the tokens. And then we're giving it that extra piece of information, which was the code verifier. So this is the plain text that created the original secret that we sent off. And we also send it the code as well. So what AAD does is it responds with a bunch of security tokens. So in this case, we get a whole bunch back. And these things are JWTs and some other information in there. So what we're going to do is have a look into the ID token in this one. So we're just going to copy that, and we're going to go to the next tool we can use to help diagnose some of this stuff, which is a website called jwt.ms. So there's one called JWT.io as well, which is really good. MS is great for Microsoft Azure Active Directory. The reason being, we have this little description of what the things in the token actually mean. So that can be really, really useful when you're dealing with AAD. So you get a whole ton of information about these different claims. But that's all it is. It's literally a base 64 encoded blob of JSON, and it roughly consists of 3 parts: the red part, the blue part, and the green part. The red part and the green part are all concerned about cryptography and digital signatures on this token. So if you remember earlier, we talked about trusting Azure Active Directory as our source of identity. So the way that trust is actually created is that AAD signs tokens with private keys, and then it tells information about which key it used to do that sign-in. So that's the red part. We can see here that it's a RS-256 algorithm, and it points to a KID, a key ID. Now, AAD publishes its public keys in what's called a discovery document. There was actually another request in Fiddler that showed my single-page app going to AAD saying, give me your public keys. Once we get the token, we can now look for that key, and we can validate the signature against the token. And if it all checks out, we trust that this token came from AAD. So we know that we can trust it, and we know who's signed in. And we get that from a bunch of these things inside the token, the properties, which we refer to as claims. So the important ones, I think, AUD. That stands for audience. Audience is who is that token intended to be used by. The audience in this case is B10, which is my single-page application. The long and short of it is, if that audience isn't you, then you shouldn't really be using that token, right? It's not intended for you. So it's very important. I've seen some scenarios in particular where people were trying to validate tokens that were meant to be sent to the Graph API. And they were calling me up because, Graeme, it doesn't work. We've got Istio on a Kubernetes cluster, and we've got a standard JWT validation plugin, and it's refusing to validate these tokens. And the more you dig around, you realize that, well, hold on, the audience isn't you, and it just turns out that Graph actually signed the token and then changed something inside the token afterwards. So the signature could never be validated against that token. But that's their business. It's the token for them. They deal with that. So if the audience isn't you, not really supposed to use it. We can see who issued the token, which in this case is just AAD. There's a bunch of Unix timestamps, issued at, not before, and expires at. But the really interesting bit for us, because it's an authentication flow, is we get told it's Santa, and in this case we get told Santa's email address. The only other thing I'll call out, because this does get people sometimes, is this version down the bottom, 2.0. So Azure Active Directory has 2 versions of its endpoints, 1 and 2. if you use ADAL, you call the version 1 endpoint. If you use MSAL, you call V2. If you're doing an authentication flow, then you will get back a version of the token that corresponds to the version of the endpoint that you use. Now, the reason for that is authentication flows, the audience is you. So it's your code that will be using that token. So if you call V1, it's a fair assumption that you want a V1 token back. If you call V2, it's a fair assumption you want a V2 token back. When you call a downstream API, you could call the V1 endpoint, but if that downstream API has shown a preference for V2 tokens, you'll get a V2 token back from the V1 endpoint. So it's all a bit kind of weird. The tokens themselves, not much different. The V1 tokens are a bit smaller than a bit bigger than the V2 tokens. But ultimately, that's if you're seeing a version thinking, but I'm calling the V1 endpoint, I'm getting a V2 token back, I don't understand it. That's what's going on behind the scenes. So that's an authentication flow. So that's half of the equation. So let's go back to the application and see what happens next. So we're going to click this button to add Graeme to the naughty nice list. And this is where my SPA is now going to try and call a downstream, one of these new digital transformation APIs, which is living on the heritage ASP.NET application. So I've told AAD to always prompt for credentials and always force sign-in, just because it makes the demonstration kind of a bit more predictable for me. Otherwise, you never know if things are cached and like stuff just happens. So we get another of these permissions requested things pop up. So we can see that Santa Light has now asked to change the naughty nice list. But the important thing here is, in brackets, Santa Web. So this is another scope. It's another thing to put in front of the user. But unlike the original auth authentication flow, this is now asking for my consent to call something on a different API, a downstream API. So what I want to do is I'm going to cancel this, and we're going to quickly go into the portal to have a look at the other application, which in this case is called Santa Web. So I just want to make sure we get the right one, because for some reason I saw there were actually two Santa Webs, so I'm not sure what went wrong with my demo there. Here we go, owned applications, Santa Web. That should do me. So I talked about scopes, and I talked about AAD having different terminology for everything, and this is another one of those. So we don't have a menu bar for scopes. Instead, we have expose an API. And again, over time, you can see the word scope has started to appear inside here. So we're starting to adopt the terminology of OpenID Connect. But I've got 3 scopes declared on Santa Web. Basically, 2 to manage the naughty nice list, one to read it, one to write it, and another to write the present delivery route. Now, the important thing about scopes in AAD, they're just text labels. They don't necessarily have any bearing or connection to the actual API endpoints that you're going to call. And this is quite important, because sometimes you see applications that have got hundreds of scopes. And you say, why have you got hundreds of scopes? Well, we've got hundreds of API endpoints. But you put that in front of a user, right? Can you delegate consent to 100 scopes? We know what they're going to do. It's like if you get a big pull request, right? If you get a pull request of 3,000 lines, you're going to spend less time reviewing that pull request than if you get a pull request of 20 lines. Or is that this? Oh, no, that's me. All right, cool. Phew, for a minute, I thought people was, no, we'll spend hours on that. It's too much to take in, right? And if you overload your brain with that, how can you look for 100 scopes and sure. So instead, think about what makes sense to your end user, just labels. So in my case, these particular scopes may map to like 20 or 30 downstream API endpoints. Doesn't matter at the end of the day. It's all about something that makes sense to your end users. I said scopes are nothing more than labels inside of AAD. That can be contrasted to some other identity providers. So identity server, Duende, for example, you can put R back across scopes. So you can actually say that these users can see these scopes. But in AAD, that's not a thing. If there's a scope against an API, anybody is allowed to consent to that scope, which has got some interesting ramifications, as we will see. So what we're going to do is quickly flick to the JavaScript code. One other thing as well. All these scopes you'll see are prefixed by API://SantaWeb. Now, again, because AAD is a global identity system, it's possible that there's another application that has got the same name scopes as you. So we namespace them. And we do that by providing this thing that's called a application ID URI. So in my case, it's API Santa Web. It has to be globally unique across Azure Active Directory. And it just allows us to uniquely reference the scope. So if we go to MSAL now, what we will see inside VS Code is that the application makes a call to acquire a token. Says, this is the scope I want. When we do the sign-in flow, we'll call that, close that one, and back to here, add Graeme to Naughty Nice list. Sign in. Accept that, and if all goes well, we sign in, and we're going to try and call the downstream API. But we get 401 unauthorized. So I'm going to take you to my next common problem that I find in Azure Active Directory. So we'll quickly grab this token and have a look inside it. Here we go. And we'll use jwt.ms again for this. So it's pretty similar to the identity token. The main things to call out, the audience at the top here has now changed to API Santa Web. And inside here, we have another claim, which is the scope. So those are the scopes that I've consented to. Little interesting fact as well, because when we request scopes, we have to fully prefix them with the API's ID. What you'll find is if you try to ask for scopes from multiple APIs, you'll get an error, because the tokens that get issued can only have a single audience inside it. So it makes no sense to ask for a JWT, which has got scopes from different APIs. Okay, so the scopes have to be within inside the same application. So everything looks good on the token, but we've got the authorization issues. So let's go to the actual API behind the scenes and see if we can find out what's gone wrong here. And we can see there's been a 401. This RAD is holding up. That's good, isn't it? And we've got an error message in here. So this is where the logs of the API can be really useful. We get told that the audience API Santa Web did not match API : and then something that looks like the GUID, the actual client ID of the API. When I requested that token, I was very, very explicit. I want an audience of API Santa Web. But when we configure the NuGet package that deals with this inside a .NET application, by default, we don't have to tell it about our custom API's ID. If we don't tell it, it makes an assumption that that audience is going to be set to API : / and then the GUID of the actual client application. So this is one of those where the reason that's done, by the way, is if you don't explicitly ask for your own app ID, then if you just ask us to create one, that's what we create, API : / and then the ID. So this is a really simple fix. I need to actually configure my application down here to have the right audience. And when we do that, so this should be API : / this is where GitHub Copilot is coming up with, surely I can help you out here, Graeme. It's like, no, I don't need your suggestions. So we can stop that and restart it. Okie dokie. And if all goes well now, we'll go back to add to the Naughty Nice list. I'm doing very well with the internet. I feel like that's going to go wrong at some point as well, but so far, so good. So this time, hopefully with the API configured correctly with the right audience, we've now added Graeme to the Naughty Nice list, so that's worked. So there's one more scenario I'm going to walk you through. I'm going to sign out this time. You see, we've got another elf that works inside the elf designers team. He's a little bit cheeky. He's called Alabaster. And he spotted something on the user interface that he thinks he can exploit. So let's log in as Alabaster and see what's going on. Okay, we already have the password. That's good. So we did a standard sign-in flow, nothing's different here. But you see, whenever they built the UI, they didn't really look at the tokens to work out if people were supposed to call various bits of functionality. So Alabaster spotted that he had this button, add Graeme to the naughty nice list, and he clicked it. And as we mentioned earlier, because we don't assign RBAC against scopes inside of AAD, Alabaster can be asked to consent to this scope. So Alabaster is just a junior elf. He's got no business updating the naughty nice list. Yet here we are, he's being asked if he'll consent to that. And he can do. He can click accept. And Azure Active Directory is happy with all of this. It's going to issue a token to Alabaster that says, yes, he's consented to add to the naughty nice list. Okay, so this is one of the really big takeaways in OpenID Connect and OAuth2. A scope is not the same as somebody having permission to do something. Just because a scope exists on a token doesn't mean that person is actually able to do that thing inside your organization, right? So you've got to break apart those two concepts. All a scope is that someone has said, yeah, sure, you have my consent to go and press the nuclear launch button, right? That doesn't necessarily mean that the application will just blindly honor that request. So this is where we start to get into the question of, well, if that's not the scope, where does that authorization actually come from? So there's three kind of main things that I see, going in kind of order of probably the worst to maybe, I don't know if there's a best in this one actually. It's going from the worst to going to the it depends. So the first is our old favorite Active Directory groups. Because who doesn't love putting in tickets to the AD enterprise team to ask for very specific application roles to be registered in AD, right? And we've seen them pile up over the years. You might get a token back in AD and it might have 1,000 groups on there. And there might be for applications that no longer exist inside your organization, but there's no connection between kind of the cleanup tasks of this and getting all of that sorted out. So you can use AD groups, right? But I find they're better for organizational concerns. So think about things like roles of people. I'm a manager or I'm a technician. But the moment you start to put application concerns in there, then things start to get a bit complicated, in my opinion. There's another complexity with Azure Active Directory and tokens. Because let's say you're in 1,000 groups. Which of those groups do we express in the JWT? Because they have a finite size. So we can only pick a certain number of them. So you might find that the group that you're looking for doesn't even exist in the token, and now you have to make more calls out to the Graph API to find out if you're really in that group or not. So you can do it, but I would say probably avoid that if you can. So it just happens that we have another concept in AAD, which is called a role. And a role is actually a really, really cool thing. Well, it was the best thing until about a few weeks ago, and my friend shattered my dreams and illusions by telling me something about them. But the idea of a role is think of a group that is local to your application. So we can create roles. And again, they're just really labels at the end of the day. So I've got two on here, Santa World Employee, Santa World Senior Employee. And then we can assign users against them. And you'll only see these roles in a JWT where the audience is your application. You won't see them anywhere else. So pretty cool. So how do we go and assign these things? This is the next great thing about Azure Active Directory. We don't do it in the application. We do it inside the enterprise application. Yeah, got to have an enterprise application to go with your application. Otherwise known as a service principal, otherwise known as a managed application. Otherwise, like, what is this thing? So I think the reason these things exist is because we have a concept of a multi-tenant application inside of AAD. So what that means is that I can describe my application in my tenant, but you can actually realize an instance of this that you can interact with in your own tenant. So if I'm a SaaS provider, that's pretty cool. I say, here's my SaaS solution. And you can say, great, well, I'm going to start assigning my own users in my own tenant to use your application. I've got my own conditional access policies. I've got my own MFA. Another customer can do that differently. Another one can do that differently. Because we all have our own, if you like, instance of the application inside our directories. And that's where we assign the roles. So we're now going into, if you like, I guess you go from almost the control plane. If you think in terms of cloud infrastructure, you've got the control plane, which is the application, and you've got the runtime plane, which is the service principal. And, oh, we're running short on time. I'm blaming that glitch of the technology. Inside the enterprise application, we can add users and groups to this. So in my scenario, I'm just going to go and add a user. So we'll add Santa and select that. And then we'll select him on one of those roles that we saw, in this case, Santa Senior Employee. So when we do that, what we see now when we run a sign-in flow, and let's just log out Alabaster, and we'll log Santa in. We'll take a peek into the JWT. Let's go to Santa. Add to the naughty nice list. So many clicks to do. Click, accept. I did this once, and because AAD is eventually consistent, the claim that it just did not appear inside the token at all. It's like, no. The demo gods got me again. So hopefully what we'll see now is inside that token, there's a new claim which has appeared, which is the roles that Santa's in. So we can use that now inside our application. I'm probably not going to have time to do that bit, but on the controller, the action inside of the .NET application, I can use a standard authorize attribute to request that role of senior employee now. Alabaster won't get that, which means that he won't be able to call that API. So roles were brilliant, absolutely brilliant, until my friend pointed out a few weeks ago to me that roles don't work with nested groups. So if you have a hierarchy, let's say you've got all senior employees and then you've got developer senior employees. So you put the all senior employees saying as a role inside your token, but someone's in 2 levels down as a user, they won't actually see that role in their token. So I just was very sad, and I have not got a great answer kind of on the back of that, unfortunately, other than like keep your AAD hierarchies flat if you want to use roles, which is not brilliant. But I think it starts to sort of paint this picture of, you know, you've got these AD groups that are very high-level organizational things. You've got your roles inside your tokens, which start to make more sense to your applications. But again, they're not super fine-grained permissions. You wouldn't have roles for every permission inside your app. So you wouldn't have one if you're a bank teller saying, here's a role for people that can give out less than $500. Here's a role for people that can give out more than $1,000. Because you're starting to bury your very specific application rules inside the identity provider. And again, I think keeping that distinction is really good. So roles, great for concepts that make sense to your application, but when it comes to the real fine-grained business logic, for me, that's the sort of stuff that starts to live inside your code, or at least is a decision that you explicitly make in your code just before you do the operation. So you might, for example, call out to some policy server and say, well, here's all my signals, here's the roles, here's the user, here's what they're trying to do, and then have some external rules engine like a policy server make a decision and say, yeah, go for it. Or no, don't go for it. And I think that's the best I've come up with so far. The more complicated, the more centrally managed you want that business rule logic to be, then the more it starts to make sense to think about policy. But the simpler your APIs are, then the more that makes sense, I think, inside your code, where it's just owned by the team and can be tested and is local, et cetera, et cetera. So that is basically the end of my talk. We've seen JWTs, we've looked at PKCE, OIDC, we've looked at AAD, groups, roles, scopes not being permissions, et cetera, and we had some fun with technology along the way as well. So thank you so much for coming today. I'm not sure if we have time for questions, but thank you.